It's actually not started yet. It's starting.
Okay.
It's starting. It's starting. It's starting. Okay, we're on.
Hi there. Today we are going to present the results of the security analysis that we have performed for Ninja Shop. We are a team of two, Daryl and me, Wei, both are software management students of class 2014. Here is the major findings we have got. So basically, we have found in total 10 vulnerabilities. Five of the 10, 5 we deem are with high risk. 3 are with medium risk and 2 are low risk. With those findings, we have also proposed solutions to fix the vulnerability and mitigate risk. So how do we find those problems? Basically, we navigated throughout the website, trying different things like creating username, login, logout, adding items, removing items, and checking out. We use the developed tools provide the browsers extensively to check the source code, network traffic, HTTP requests, the cookie settings, and the certificates. We also tried to emulate the text by, for example, searching some strings that contain JavaScript. Now let's look at what we've got. First, we found the Ninja Shop is pretty weak in terms of input validation and sanitization. It has a search box, and when the search results is returned, the original search items is reflected. So we are basically able to display a cookie in a little box if we search this string with 3 leading double quotes. What's interesting is that the input validation is not a total failure. It actually works for 1 double quote and 2 double quotes, but not 3. So for Firefox, we were able to actually display the cookie by using XSS. And for Chrome, it's a little bit different. Chrome actually was able to detect this kind of a reflected XSS attack and refused to execute script. But we can see that in the debug console, actually, it's kind of working. Just the browser is more sophisticated to identify the risk. Now let me switch to Daryl.
Thanks, Wei. So Wei already mentioned cookies. So by simply logging into the site and trying to use it, and then going into Chrome and looking at the cookies that were set on our own machine, we're able to see that the website has an initial cookie that it's offering the user, and then upon login, they're correctly regenerating a cookie, a secondary cookie, in the hopes of slowing down an attacker. The problem is, if you actually look at the cookie in your own browser, you can see that they're both are unsecure. So by comparison, Google Drive uses a secure cookie with HTTP only, and these 2 cookies are totally unsecure. So that makes it easier for a hacker to potentially steal the cookies. That's Wei had just succeeded in doing. If we go on to look at the next slide, we'll notice that the error suppression on the site is low. So in this example, upon registration, I don't think it's designed to actually even really register, but I attempted to. It actually dumped the error message, and in this case, it's dumping the SQL statement that it was trying to execute, which gives me the symbol. So it tells me that customers_info is a table in the database, probably a very important table. So if I were successfully able to inject SQL, I can use this information to do something like, let's say, drop table, which would obviously have catastrophic implications for the site. Moving on to the next piece. This is a little bit lightweight. Many sites do this. They'll offer the ability for the user to save their password on the machine. Never for this site. You've seen that many times. So it's kind of lower on our list, but they have autocomplete turned on in their scripting. Will probably be a better practice, especially if it's a site that people will be logging in maybe remotely from a lot of public computers. You may want to turn that off so someone doesn't, use that feature when you don't really want them to, and then maybe walk away from the machine and it's still there. So that's lightweight, but it's maybe a better practice not to do that. So clickjacking. So here we see some very lightweight frame busting code. You could actually do better than this. So we actually were able to break it by using clobbered as a location to basically bust out of the frame. In at least my quiz, I actually did the 204 error, 204 page technique where it repeatedly tries to go to the 204, and then that it kills the navigation that way, and then it basically keeps the frame, the page framed. So you could defeat that using that technique as well. And then finally, you could use potentially the X options, which of course doesn't work in every browser, but it's something that of course we learned about in class. So finally, getting on to the final few things on slide 12 here. So the very first thing we noticed was the login page itself is HTTP only. It's not even HTTPS. So there's no secure pipe, meaning that there's opportunities to so the simplest, an eavesdropper, a passive network attacker could actually sniff that information on a network at Starbucks. Even worse, potentially put up an access point at Starbucks because they always have ATT Wi-Fi, and you put up a Starbucks one, they can get someone to log on to yours. Either way, there's the opportunity to basically monitor that traffic and pick up not only the username and password, but in other parts of the site, other key personal information, so obvious weakness. A lack of secret validation token, so they're only using a cookie, they're not leveraging the idea of a secondary key to basically secure the site in their, for example, in a forum post. The third bullet here is self-signed certificate. That's not strictly speaking a security issue, because that's giving you a secure tunnel. It's a perfectly valid thing to have your own certificate, but from a trust indicator standpoint, probably not the best practice for a commercial site, because it obviously will show a warning message to the users as opposed to using a validated certificate from a certificate authority where they're not going to see that messaging. And then finally, something a little more serious, mixed content. So on some of their HTTPS pages, secure pages, they're actually embedding referencing links HTTP, which obviously opens up the opportunity to defeat the security. So with that, that is our presentation. We've loved taking the class. And so from Daryl Chapman and Wei Zhang, thank you very much. Bye now.